What's up, guys? Welcome to today's show. So today we are going to code an interactive C interpreter, and I'm going to show you what I mean by that. We have those in different languages like Python and Haskell. So in Haskell, for instance, you can do something like let x is equal to 1 plus 2, and then you just press x and you get the result. Or you can do let str1 is equal to foo, let str2 equal to bar, and then let result equal to str1 and str2. So I want something similar to this. I want to be able to create variables, assign values, and list the value. And Haskell also has something you can type :t and then a variable, for example, or any statement or expression. And then you get back the data type of that. So I want to have that functionality as well. And in order to create a really good interpreter, you actually need to create a compiler, basically. So I'm not going to do that much of an ambitious project. I'm going to create, at least version 1 will be a naive version, where we use GCC and we produce temporary .c files. And if everything works, maybe we can move on to more advanced stuff. So I'm gonna by the way, those are usually called REPLs. It stands for read eval print loop, and that's basically what it is. So I'm gonna call my C REPL because it's a REPL for C. And I'm gonna create it by using bash bs c REPL, and I'm gonna use C template, go into the directory, set it to my home, and when I use bash bs, it just creates my basic structure. And you can download that from the repo if you want. All right, so let's see. Let's go into the creeple directory and open it up in VS Code. And I use C2X here. If your compiler does not support that, you can just delete this std part. If you have a very new version of the compiler, which I do, you can even do C23 here. So I'm going to do that. And this is the basic structure. So basically just a couple of integers, burst utils, which you can also find in the repo. And the C file is pretty much empty. All right, so how do we do this? Well, the API is going to look something like this. I'm gonna have two main functions. So let's call them, let's call one of them type. And that will return a data type of type. So this is type, and it's going to take let's see. Let's start by letting it take a variable, at least. Yeah. And maybe even a variable pointer. And it returns a data type. And I also want to have some void function which just prints that thing. So let's say void show type. And this will take it in a type as a parameter. So let's make this a pointer too. And before we move on, let's define these different data types. So first of all, we need to have a type data type. So let's create a struct s type, or is it enough with an enum? Will this carry any additional information? I don't think it will. So maybe we can just make this a non-pointer. And then we create an enum instead here. So we'll have an e type. And let's say we support int and char for now. And we will type def our, and this should not be a struct by the way, it should be an enum. So we'll type def our enum e type to type like this. Okay, that's easy. So let's define our struct, which is a variable. And what does a variable contain? Well, it has a type, right? So let's say data type. And this needs to be a type. It should also have an identifier. So let's say, yeah, let's do identifier name like this. And then we can just type def char or int 8 to identifier. So it has a name, it has a type, and it needs a value as well, right? So let's see. A value. I guess we need to make this void value, because it should be able to deal with different types of values, right? Integers and all that stuff. So let's say we type def our struct s variable to a variable like so. Alright, so that's what we need at this point. Let's also create some constructors. We don't really need one for the enum types since it's very easily constructed. But our variable we need one for. So it's going to return a variable pointer, make var, and it's going to take a type, an identifier, and a value. So let's start defining this. We're going to have a constructor function which returns variable, make var, and it takes in type and an identifier and a value. So let's see. Yeah. So void value, and all we're going to do is check that we have these things. So, by the way, let's have a void here as well. Or actually, let's have a nothing. Because I want the nothing to have 0 as a value, so we can complain if it's 0. So if we don't have a type, or we don't have an identifier, or we don't have a value, in that case we will return a 0 cast as a variable. Alright, so we need a variable for the return thing. Let's call it p. And we also need to have a size for this. So let's say size is equal to the size of a struct s variable. P should be malloced. And if we don't have a p, we can also return an error. Otherwise, we zero out the p using our zero function from the birch utils. And we need to cast this to an integer, to an int8. And now we just need to set the different fields. So p type will be type, p identifier, what did we call it? Data type name value. And then we return p. Simple enough. see. Maybe we should create some macros which create different kinds of these. So we allocate for the value as well. And what do I mean by that? Well, let's say for instance we create something like a what should we call it? New int. And this will only take a value x and an identifier y. Maybe we should call them better things. So let's say the name and the value. So what are we going to do when we call this macro? Well, first we need to allocate for this value. So let's do, or can't really do. Maybe we can do this. So we will have a pointer and we'll have a name and we'll have the value. So if we do it this way, we can create a do block. So let's just do something like, let's first create a temporary thing. So let's say int tmp. And we want to set tmp equal to malloc and size of int, or int32 to be precise, because that is what we're going to support at this point. Let's make sure we have a tmp. If we don't, we will set our return pointer equal to 0. Otherwise, we want to copy the value to this new thing. So tmp should be equal to no, not like that. The dereference tmp should be equal to the value. now that we have the value, we can create the actual thing. So our p should be equal to, and then we call this make var, and type is going to be an integer. The identifier is going to be the name, and the value is going to be our TMP. And in case we don't have a P, then we want to free our TMP. And we'll do the while false trick. So we so this will not loop. But this should be an int32, by the way, and we want to cast as int32 as well. Because if we do it like this, we can just call this new var, and we take one additional parameter, which is the data type. So then we can do this. I'm not sure if it works with the parentheses, but let's try. Because if we do it this way, we can define new int and just say this is an int32. I mean, we take in the p and v like above. But the only thing we do is we call new var with an int32, and we pass on the p, the n, and the v. It's good to have the parentheses here in case we want to provide an expression. And now we can just make one more of these, and suddenly we support chars as well. Strings, however, which I also want to support, needs to be dealt with a little bit differently. So let's create a new string with a p and v. And we'll do this similarly, but not exactly the same. So we want to have int8 star TMP. TMP, we need to know the length of this thing. So let's also define, how should we call this? Let's just do TMP2. This will be the size. So let's start with that. TMP2 should be equal to, and now we need to have a string length function. So let's say we have something which is called length, and we provide the value. So we need to make sure we have a value. Or maybe our length function can return 0 in that case. So let's say if tmp2 is 0, then we want to set our destination pointer to 0, and we want to break. Okay, otherwise we know the length, which means we can allocate. So tmp should be equal to malloc tmp2. If this is 0, forgot to break here. So if tmp is 0, in that case p should be 0. And we should break. Otherwise we should copy our value, which means we also need to have a copy function. So let's run, or a string copy. So we want to copy into our brand new tmp. We want to copy from the value, and we want to copy tmp 2 bytes. And now we can create our thing, which means we can set p equal to make var, and this should be a string with a name and tmp as the value. If we don't have a p, in that case we want to free our value variable. And we'll only run this once. Okay, so now we can create variables. Before we move on, we should probably test this. So let's see. We want to have a variable p, p should be equal to make new string, and it takes a destination point. Alright, we don't do it like this. Give the pointer here, and then we need a name for this new variable. Let's say str, and we need to cast this into an int8 string. And the third is the value, also an int8 string, so let's say foobar. And if we don't have a p, let's print some error. Otherwise, we can do something like type let's see. So this means that we want to print a byte, or maybe 16. Yeah. And then the name. By the way, this should be %.04. And then we have the name, and finally the value. %s, like so. So the first is going to be the p. What did we call it? Data type. Then p name and value. So we'll free the p, and we want to return 0. But we also need to create those two string functions. So let's do that. The first is just a string length thing. So let's say we have, I don't know, an int16 string. What did we call it? String len. And this should take an int8 str. We need to have an int n and an int8 p, to a for loop where we set n equal to 0, p equal to the string. We iterate as long as we have a p, and at each iteration we increase n and p. And then we can just return n. But we also want to check that we actually have an str, otherwise return 0, like so. And let's also create this copy function, which is pretty similar. So we'll do void, I never remember what I call the functions. So let's see, string copy and length. Maybe we should call this copy then. So this is the length, and is copy. So it's going to take a destination, source, size, and we need to have a destination pointer, a source pointer. We also need to have an int16n. Do a for loop. Destination pointer should be dst. Source pointer should be source. N should be size. And we want to go as long as we have an n at each iteration, n minus minus. D pointer we increase, and source pointer we increase as well. And then we just want to set the destination pointer to the source pointer at every position. And maybe add a 0 byte at the end. Yeah. So we will increase the destination pointer and set that to 0. I think we can do this, right? And return. Let's also not forget to create the signatures for these string functions. So we'll have an int16 length that takes in an int8 star, and we will have a void copy which takes an int8 star, an int8 star, and an int16. And now I think we have what we need to test our first thing. So let's make this stuff, see where we error out. Type def enum etype. I knew something was wrong with this H file. I couldn't put my finger on it. This needs to be terminated. $1 undeclared. Okay, I thought I had those. I need to change the name. I have the old standard. So this should be 1 byte, 2 byte, 4 byte, 8 bytes. P-type is equal to data type, has no member. Right, so this should be data type, this should just be type. Assignment to variable star from incompatible pointer int 8. So let's see, new string. TMP is an int8 star. And we malloc this as an int8 star. Right, this should not be $10, it should be variable 0. Well, here too then. Because this should always return variable. Assignment to variable from a compatible type int. Okay. 46. Same here. And then we just have one more thing. Expects argument of type char. Alright. So when we print this, we need to cast it into a char. And the data type we want to have as integer, and the name should also be a char. And now I believe it will compile. Yes, but will it work? Yes, it works. Let's also see if we can create other things like an integer. So instead of new string, this will be new int. And let's call this I. And the value something like this. Okay, and when we print this thing, we need to print the value as D. So this should be an integer, and we need to dereference this thing. Oh. TMP undeclared. Maybe this is not something we can do. We do not want an expression there anyway, so this is actually better. Let's see. Referencing void pointer. So maybe we need to do in 32 star this. Something like this perhaps. It's always tricky with this void pointer. Okay, that worked. So let's try it. And it works. Pretty nifty. And if this works, the char will work as well. Okay, so now we can create a variable What else do we need to do? We need to have this .c file is what we will run as the actual interpreter program. But the code we will run is going to be a separate file, which are dynamically created, but they will have a common structure, so some functions which are common to them. So let's define these. Let's go to the make file, and let's say we do have we want to create a common.o from common.c by running cc with some flags, input file, output file, possibly some LD flags. No LD flags. And -c. Let's say we have a common.h as well. And what do we want to link this against? Well, at least for testing purposes, we can link this to our main thing, but we probably don't want to do that when we are done with this. Right, so let's create common.h. And common.c. So let's restructure a little bit. Make file we can close. Let's say we have the C files to the left in this order, and I defined those here, the type and show type. Both of these actually should be inside of here. And we do want to have these as well. Maybe not all of these, by the way, but at least this. And these. And we also well, we need to have these as well, or maybe not. The variable. But the type, I suppose we need. Or maybe not, actually. We will do that stuff a little bit differently here. Okay. And then here we just want to include common.h. Okay, so let's create those functions. So this should return the type of a variable. Actually, I think I'm going to do this differently. Let's not have a variable here, and let's not even have a function actually. Let's instead create a macro. So let's define type. And this is going to take a variable or an expression perhaps. Let's say it's an expression. And what do we want to do with this expression? Well, I want this to be a generic function. And I'm not entirely sure about the syntax here. But something like this. And then it's going to take different data types. Well, the input first, which is the E. And then I think we do something like, if this is in 32, for instance, in that case I want to return in 32 as a string. And if this is a well, if this is a char, let's return char, and the string will be represented as int 8 star. So let's say that's a string. As I said, I'm not entirely sure about the syntax here, but it's something along these lines. Let's see if it works. If we go to this one and we clean out main and we try out this function. So basically we just want to print f something, and this something should be the type of x, where x is an int 32x. Something like this. And then we need to include this, and I hope it will not clash. expected identifier or blah before generic. I'm not sure. Maybe we can just do this for now. And what if we were to add a regular int? Will our expression work in this case? Huh, cool. And what if we just put a regular string in here? Let's remove these. And let's say hello world. Char star. This is pretty cool actually. So now we can at least print the type of the stuff we are using. Yeah. So inside of this crepl we need to have some function which reads from the standard input, because we need to have a shell basically, and we will do this shell like with arrow support and all that stuff, but not in the beginning. So it would be very simple. We do, however, need some kind of read line function. So let's say we have something like int 8 read line. So we'll just read from standard in, and we need to remove the new line at the end. So let's see. I think I want to do it like this. Int 8. Let's create a p and a ret. And a size. And maybe some temporary buffer as well. Let's say we read 128 bytes. So let's start by zeroing out this buff. And 28. Then we want to set the size equal to we read from 0, which is standard input. We want to read into our buffer like this, and at maximum 127 bytes. So let's say we read ABC new line and a 0 at the end. In this case it would say that we have 4 bytes. And if we add indices, this is 0, 1, 2, 3, 4, like this. So our size minus 1 is the index of the new line. So let's just do let's set p equal to buff plus size minus 1. And then we set this to 0. Maybe it's cleaner to do this actually, because we want to reuse this and we want to allocate. So our return will be a malloc of size bytes. And then we want to copy this thing, so we'll do copy into ret from buff size bytes. And let's also clean out this first, so ret and size, and then we can return ret. Something like this, no? So if we have an int8 command, for instance, command is equal to, let's do something like printf c REPL, and let's flush. Then we set our command equal to readline. And then we just print that line. Free the command and return. Maybe we can also do before allocating, let's check if the first byte of buff is 0. And in that case we can just return 0 without allocating anything. Okay. I guess we should cast this. Right. that works. Okay. So let's create some kind of a main loop. Let's create a boolean. Continuation. And let's have a C pointer for that. We will set continuation to true, meaning we should continue the main loop. And our continuation pointer should be equal to the continuation. And while we have a continuation, we should do our main loop. And we'll pass our pointer. So we can set that value when we want to quit. So void main loop, and we will have the bool C pointer. Let's say let's do prompt. And command. So if we have a command and if that command is exit, then we want to set our continuation to false. Something like this. And now we just need the prompt. And for now, I will just do this. Maybe we can have a copyright symbol. Since this is the C REPL, a copyright symbol, a C, could be our logo or something. So we can have this C. And use it as a prompt maybe. And let's also create some signatures here. So read line we have, and we will also have the main loop, which takes a Boolean pointer. And we have a void prompt, which takes nothing. Unused variable CMD. Right. Don't need this anymore. And this should be the address of this. Okay, that didn't look really nice. It works though. But why did it look so weird? What if we put a space here? Still weird. Let's copy this thing. And let's do a hex dump. A9. Let's try doing A9 instead. Huh, would you look at that? Okay, so we have the general structure. And the next thing will be to try to define variables. Yeah. And then we need to turn our variables into C code so we can dynamically generate that thing. And then we can show we'll be able to show values as well as types. So I think this is going to work actually, in some sense. But I think this will be all for today. If you like this project, don't forget to subscribe and hit the like button. But subscribe and also click the bell if you want to be notified when I drop the next episode in this series and in all other cool series, like the NSA backdoor playlist, and I have a lot of fun stuff. So thanks for watching, thanks for today.